Hello, welcome back to Learning with Ms. H. Today we are going to be looking at our Earth Science lesson on formation of the solar system. So, first thing you're going to see here in the starter box is that there's a vocabulary quiz to take. So if you click on that, it will pop you over here into your vocab quiz. It's only one question, but there are 11 concepts here that you're going to match with the correct term. So you have a drop-down menu here with all of your terms. You are just going to select the correct term from the drop-down to match the concept that's given to you. Obviously, these are not all solstice, but this is the idea. So you'll choose the correct option from here. Once you've finished all of these, you will turn it in by hitting the submit button here. And then it will tell you the score that you got. You can't change your answers once you submit. However, remember that these quizzes that are on Canvas, you can retake. You can do these as many times as you need to get 100%. This one's going to be a very bad grade since I put the same word on everything. So I got no points out of 11 because I missed them all except for this one. So obviously only one of these is going to be a solstice. And then it will also tell you the correct answer down here. So you can try this again by just going back into that assignment and clicking it again. So retake this as many times as you need to get 100%. And then come in here and work on the notes on the formation of the solar system. They're embedded down here. Once you get done with those, you'll complete the homework assignment, and then you are done for the day. So the homework assignment is linked down here in the assignment section, and then you have a reminder that your vocabulary is due on Friday if you've not already turned it in. So let's get started on notes for formation of the solar system. So you'll put today's date, and then the title is Formation of the Solar System. As always, when we go through these notes, if you need to, you can pause the video, finish up the slide you're on, and then restart the video and pick back up with us. That is always an acceptable thing to do, and it is probably a necessary thing to do because I'm not going to spend a lot of downtime on these slides because I don't want the video to be an hour long. So, work through these at your own pace, pause and restart the video as necessary. Starting off with formation of the solar system, the main questions that you need to be able to answer today: how did the solar system form? Why do things orbit and spin the way they do? Why are the inner and outer planets so different? And when did the solar system form? Those 4 things. And you should be able to answer all of those questions after today's notes. So we're going to talk about a couple of phases for how the solar system formed. The idea behind this is called the Nebular Theory. And the idea of the Nebular Theory is there's 3 stages: gravitational collapse, condensation, and accretion. So we're going to talk about each one of these phases individually. If you'd like to write down the order, please go ahead and pause the video here. So this image is solar systems that are in different stages of being formed. So you'll be able to see all 3 of the phases: gravitational collapse, accretion, condensation, all of those phases in these images here. So they're just some different views of various solar systems. It's kind of like seeing somebody grow from a baby to a teenager to an adult. You're just looking at the lifetime of the solar system here. You don't need to write down this slide. You don't need to copy down these images. This one's just here in case you're interested. So stage 1 is gravitational collapse. Basically what's happening is your star is starting to form. So all of that stuff we did on life cycle of a star, it's happening during this gravitational collapse phase. Everything's starting to get pulled inward. You have some heavy gravity happening. It gets pulled in. Things start bumping into each other, having collisions, causing that fusion to start happening. So your gas joins together, becomes a protostar, fusion starts, and then you have your star forming. So that is the heating phase of stage 1 gravitational collapse. You form your star. Everything starts heating up. As it heats up, you start having random motion become more organized motion, and it's going to start spinning. Everything out in space seems to go counterclockwise, so it's going to be spinning around that point of gravity in the middle, which is the new star. As it spins, it's going to start flattening out, because what's happening is it's throwing stuff out away from the star. The faster it spins, the more momentum it gets, the more it throws out. So while everything's trying to collapse in here, this momentum is still throwing things out away from it. All this stuff that's being thrown away is called a protoplanetary disk, and that's where our planets are going to start forming. Stage 2 is condensation. And it's not necessarily condensation like you would normally think of, like the water forming droplets on the window. It is condensation in that it is so hot that everything is in a gaseous form. There are no solids or liquids right now around this new star because it's so hot. Eventually, you're going to get out here far enough away that it's going to cool off. As it cools off, it's going to allow things to solidify. So once it gets past what's called the frost line here, things are able to start solidifying and come together. The cooler it gets, the lighter the element that can condense. And they just form solids. So inside the frost line, we've got a couple things going on. That frost line is where ice can remain solid in direct sunlight. Inside that frost line, we start having inner and outer planets forming as you get further away from the sun. And the way that works is the further away you are, the lighter the element that can solidify. So these inner planets are closer to the sun around this soot line here. And that's going to allow heavier metals and carbons and things like that to solidify and become protoplanets. In here towards the sun, everything is gas and nothing is able to hold together and really organize because it is so, so hot. So this inner region, only metals and minerals are going to condense into planets. And that's where we start getting our inner planets, is down here towards the soot line, the outside of the central region, right along the soot line. We can condense carbon and some of our lighter metals, and we form our inner planets. Once you get past that soot line, now you're in this red area, and now we're able to start getting lighter and lighter elements. So this is where most of our planets live, is in this red area. Once you hit out here in the frost line, we can start having lower, lighter elements condensing. So as we approach that frost line, you're going to start having the gas giants form out here. So near the soot line, generally on either side, it's not like hitting a wall. It's not a barrier like hitting a wall is. It happens gradually. So right here in the vicinity of the soot line is the inner planets. And then as we work out towards the frost line, we get our outer planets. And remember, they are condensing, so the gases are turning into solid particles. They're not joined together yet. They're just turning into solid particles at this point. So condensation, becoming solid. Stage 3 is when they come together. Accretion is the bonding of those particles, the coming together of those particles. Basically what happens is the sun is blowing out these ionic solar winds. An ion is a charged particle. So solar winds with lots and lots of charged particles. When a charged particle hits something, it causes it to become electric. It's just like static electricity. When you rub your feet along the floor and then touch something metal, you get that little spark or shock. It's the same thing. So as those ionic winds from the sun go out and they go past all of these now solid objects, they electrically charge them. Anything that has an electrical charge can attract other things to it. So as all of these get charged, they start coming together and drawing each other in and getting larger and larger. If you guys have hardwood floors anywhere and you've ever seen like the big dust bunnies that gather either underneath a couch or under a cabinet or behind a cabinet, the little fluffy bits of dust and dirt that kind of come together in a chunk. They're usually pretty airy and fluffy, but they give you the same idea. They draw all those other pieces of dust to them and get larger and larger the same way these objects in space do. So as they get an electrical charge, they draw everything else to them until they get larger and larger. All of that together is going to eventually form what's called a planetesimal. That is a vocabulary term. Hopefully you've got it on your vocabulary already. That term is guaranteed to be on the test. 100% planetesimal will be on the test. Please know what it is. It's basically all of those particles coming together and joining up to form what will eventually become a planet. So during the accretion phase, that's when you have planet formation. You start off with the planetesimal, which is super small, generally between 1 and 100 kilometers. In the early system, there were hundreds of thousands of these. The next stage, as they continue getting larger and larger, is a protoplanet. A protoplanet is basically a dwarf planet. They qualify as a planet in every way except one usually, and a lot of the time that one way they don't qualify is by not clearing their orbit. This is an image of Ceres, which is in the asteroid belt. Ares is in the asteroid belt. Pluto is out past the 8 planets that we have. It used to be the 9th planet, but it has not cleared its orbit completely. It has other objects in it that do orbit the sun in the same path. So they removed its planetary status and put it down to a dwarf planet status several years back. We currently have 8 actual planets in the solar system. And again, usually the difference is these have cleared their own orbits. Sometimes it's one of the other qualifications. That's the most common one. So you do need to know what the 8 planets are and what their differences are. I guarantee you will need to know the blue planets. Be aware of them and all of their qualities, what causes them to be blue. That is a test question as well. So make sure you know the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Uranus and Neptune, however you want to say it. Know the 8 planets. Know that Pluto is not a planet because it did not clear its own orbit. And then know what a planetesimal is. Orbits and spin. This is also a test question. There is an image similar to this that is on the test. It is actually the image from your homework assignment. Very similar to it. It's going to give you the Earth in 4 points of the orbit, and you're going to tell me which point is the fastest. What happens is we have an elliptical orbit. This image is greatly exaggerated. We are just barely elliptical, so we would more likely be down around this area here, towards the middle of this space between the sun and the apogee. However, they elongated it and exaggerated it to allow you to see the point a little bit easier. So we orbit around the sun in a counterclockwise direction, parallel to that solar plane. So that protoplanetary disk that got thrown out, that's where all of the planets formed, so that's why we orbit here. Slightly elliptical, and then you have two vocabulary words here, perigee and apogee. Perigee is going to be the point where we're closest to the sun. Apogee is furthest away, and again, it's not that big of a difference here. Apogee is really going to be right around in here. But the perigee is where we're closest, and the closer we get to the sun, the more gravitational pull is on us, the faster we go. So we come around here and we kind of slingshot around. So we'll go slow, 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 speed up a little bit at a time, and then we just zoom around and come back to the other side. So we kind of slingshot around the sun there. So faster where we're closer, slower where we're further away. And I guarantee you that is a test question. I would take a minute and jot this image down in your notebooks and make a note or a star or highlight or flag it or do something to indicate that you need to make sure that you're studying this picture. You will see this again in your homework with a couple of Earths added in here. I would jot that down as well. And just add the Earths in here on the same image, totally fine. Okay, so solar winds come, they push everything out away from those new planets that have formed, everything spreads out, and then we start having the solar system build here. So this is what the solar system then would look like. So how do we know how old it is? We've got something called radiometric dating. We're going to talk a little bit more about this when we do geologic timelines and that kind of thing, and carbon dating and how that works. There's basically radioactive atoms in all of the rocks that we can find, and we're going to do radioactive dating to figure out how old they are. They have what's called a half-life. So however long it takes to lose half of the original substance is called a half-life. So if it takes 10 years to go from 100 grams to 50 grams, the half-life would be 10 years. So then every 10 years you would lose half of it. So we'd go 100 to 50, 50 to 25, 25 to 12 and a half, 12 and a half to 6 and a quarter, 6 and a quarter to 3 and an eighth, and on down. Every 10 years we would lose half of the sample. And it doesn't really disappear, it just turns into something else. So that is radiometric dating. We measure that original substance and how much is left. And we can tell then how old that sample is. So we've determined that the Earth is about 4.5 billion years old. We found samples from the moon that are 4.5 to 4.6 billion years old, meteorites that are about 4.5 billion years old. So that's what kind of gives us our clues that that's how old the Earth is. Once you are done with this slide, you are done with the notes for the day. Go ahead and move on to the homework. So your homework for astronomy is linked here. It's also linked underneath the slides again. And this is a graded quiz. And again, it is multiple choice matching. There's true, false. Here's that question that I was telling you about that has multiple Earths on here. And you're going to tell me which one of these positions we would be moving the fastest. So would we be moving fastest at A, B, C, D, or E? Please make sure that you can answer this question. You will have something very, very close to this on the test. Once you've answered all of these, go ahead and submit it. And if you're not happy with your score, you can always take it again for anything that's on Canvas. That is it for today. We will see you next time.